So now I was going to give an example. So first let me write what we studied about the additivity. It said that probability of A union B gives probab is equals to probability of A plus probability of B. Okay. So now I'm going to do an experiment. I'm going to do an experiment which involves rolling a die. It involves rolling a die and I properly dice rolling a dice should be here and tossing a coin. It is involving rolling a dice and tossing a coin. Fine. Now what I'm going to do is see, this experiment will give me some sample space that will contain all possible outcomes of this experiment. So let me write that sample space as since the sample space is set, I can use simple roster form to write it. Okay, simply write it as the possible outcomes would be the rolling dice can have take value from 1 to 6 and coin can take values heads and tails, right? So first it can there can be one and a heads, then there can be two and a heads, up to there can be up to six and a heads. So these will be the combinations of number of numbers that occur in the die and heads. Then there will be outcomes where tails occurs, right? Instead of heads, tails occur. So 1 comma t, one will there will be a 1 and a t, and then there can be t 2 and a t, there can be 3 and a t, up to 6 and a t. Okay, so this I can say is our sample space here, right? Now inside this experiment, what I'm going to do is test the probability of a condition. Okay, now this is what we do, right? So either we test the probability of any single outcome. So let me just okay, if I have to find the probability of a single outcome here, what will it be? And the total number of outcomes here are 12, if you see, right? 6 times with heads and 6 times with tails. So total number of outcomes are 12. And so if the probability of every single outcome becomes 1 by 12. Okay, every single outcome's probability is 1 by 12. Okay, now what I do is I take a condition that I have to check. I'm going to check a condition which says that, let me just erase this here. I need some space here. So what does it say is, and the condition here is that I have to check the probability of something. I have to check. I'll write it in a better. I'll just say probability of, let's say probability of getting heads. So now the outcomes of the outcomes of this condition can be written in a set, in another set which contains the outcomes of this event, right? So I can what when am I getting one heads, when am I getting a head? These six outcomes up to one, from here to here, when there the dice rolls 1 to 6 numbers from 1 to 6 and coin tosses with a h. So I can include all this inside this set I'm writing, right, which contains outcomes of this which contains outcomes of this condition we are testing, right? So I can write it 1 comma h, 2 comma h, up to 6 comma h. So their number would be 6. There are 6 possible outcomes here, right? Now, one thing what I can do is that, because this is a set here, or this is a set of possible outcomes here, what I can do is write it as, if I have to find the probability of it, what I'll do is first I'll say probability of h, this condition, probability of this condition is probability of this whole set. I'm just writing this set h as, see, what I can do is I'll consider each of its element as a single set. Okay, I am considering every element as a single set. I am writing it like this. This is one set. Then second outcome can be this 2 comma h is another set. I'm writing it like this, because and it makes sense, right? We studied about union, right? So if I union every possible outcome, what will I get? I'll get this h, right? So I'm writing it in the similar way. I'm just writing it the union of 1 comma h, the union, I'm considering all of them as single sets. Okay, so union of 1 comma h, Okay, let me write it in a better way. It is getting some mess here. It is getting messy here. So let me write in a better way. So probability of getting H would be probability of now expressing H as union of individual sets. So union of 1 comma H union. Now not going to include these curly braces, right? I'm just doing it quickly here. So union of, I can say, 2 comma H with union 3 comma H up to union 6 comma H. Makes sense. This will finally, what will this finally give out is H. Okay, so probability of H becomes probability of union of these individual events. This is what our this is saying. This is what now I'm going to use this here, this axiom that we studied. Now union of these individual events should be should be sum of the probability of individual events, right? So let me just based on this axiom, what I'll write is this whole expression will become probability of 1 comma H. Instead of union, now I have to write plus, right? I'm gonna write plus and then probability of 2 comma H plus probability of 3 comma H up to probability of 6 comma H. Make sense? So sorry, this curly brace is not here now. I'm adding these probabilities based on this axiom, right? So now what is the probability of every single event? Every single event, the probability of every single event we found out was 1 by 12. Here the probability of single event was 1 by 12, right? So let me, what can I write is probability of this P1 by H will be 1 by 12 plus second one will be 1 by 12 up to this sixth one would be 1 by 12. So I'm going to add these probabilities. So since there are six of these outcomes, there will be six of these possible outcomes. So this is simply 6 into 1 by 12. This I can write it like this, right? Now when I multiply it, it will become 6 1 by this is gonna be 1 by 2. So probability of H, probability, I can write it, probability of H is equals to 1 by 2. Probability of this condition of getting a heads is 1 by 2. And is it true? We can check it in this way. How many favorable outcomes we see here by the general formula? How many favorable outcomes do we see here? We see that the favorable outcomes are 6, right? 6 number of outcomes contain heads. So 6 numbers are favorable outcome. Total number of outcomes are 12. So this also gives us 1 by 2, which is same as what we get from here. So this is an example of additivity axiom. Okay, I hope it clears things up.